After viewers watched my Which Wire Splices Best video, many requested that I made another video testing AC mains electrical wire connectors, the popular types that you see right here. So in today's video, we're going to be putting each one of these connectors to the test. I'm going to be using the same testing method that was shown in a previous video. If you haven't seen that video, there'll be a link posted at the end of this video. When I test each one of these connectors, I'm going to be using the identical length of number 12 solid copper wire. I'm going to place a constant load on each one of these connectors for 15 minutes. It's going to be a high current load, around 18 amps. And while it's under test, we're going to measure voltage drop across the connector. And after 15 minutes, we're going to measure the temperature of each one of these connectors using my thermal imaging camera. Now the connector over here on the right has been around for ages. It is a wire nut. I've been using them for at least 32 to 33 years. They provide a very secure connection between two or more wires. Inside the cap is a metal spring. When you take the two electrical wires that you'd like to join together, strip off a half of an inch of the insulation, roughly 12 millimeters, place the two conductors side by side. You then slide the cap over, twist very tightly until you see the conductors start to wrap together, and you're good to go. A very strong connection, and they do not come undone when you do it properly. If you're going to buy these connectors, 100 in a box, they're roughly 6 or 7 cents each, so very inexpensive. The next connector over here is made by Ideal, designed for solid or stranded copper wire, and that applies for all of these you see right here, solid or stranded. This is a push type. If you buy a 100 count box of the Ideal connectors, they're about 2.5 times the cost of the wing nut, which is not too bad, between 15 and 18 cents each. So what you can do for this one is take each one of the wires, you're going to strip off a half of an inch, you're going to slide it all the way in until the copper conductor reaches the end of the connector. When you have a wire nut, if you want to check for power, the only way to do it is to take your probe, insert it right into the cap. Make sure you make contact with the conductors or the metal spring inside the wire nut, and then you would measure to ground. In order to test with the Ideal connector, you can't do it where the wires go in because it's extremely tight, very tight fitting. So you'd have to take a probe and insert it right in that little notch, go all the way in and touch that metal spring plate. You go between the spring plate and ground, and you'll be able to measure if there's voltage present at that connector. Now with the Wago 221 connector, you can see there's two openings here, and when you look inside, you can see it better right over here. It looks like there's two doors that are down, almost like a brass color, and when you lift the lever up, it opens, and in this image you can see one is open, one is closed. You would strip a half of an inch of the insulation, 12 millimeters, and once it's all the way into the connector, you would take the lever and push it all the way down so it's flat. Once it's in the down position, it's locked, and all the tension on that metal inside the connector is now placed on the conductor. On the back side of the Wago, right over here, there happens to be an opening right over here that you can insert a probe to measure between the connector and ground. The Wago 221 costs roughly 33 to 35 cents a piece if you buy a 100 count box. So that's almost 6 times the cost of a wire nut. The last connector is very similar to this Wago, it's just a different style. It's got plastic levers you pop up, and over here on top is where you would probe to measure for power in this connector to ground. So when you look inside this connector right here, it looks like what you see over here. And then when one lever's up, you can see how the wire slides right inside. Once the wire's inside, the same thing, you pull the lever all the way back down to lock it in place. If you buy a 100 count box, you're looking at 23 to 25 cents a piece, so roughly 4 times the cost of a wire nut. Right over here you can see the first wire we're going to be testing, and on each end it is crimped and soldered with a male blade connector. I'll show you in a minute how it's going to be connected up. All the wires under test are going to be number 12 solid copper wire, all cut the same length. When current flows through a wire, you're going to have a voltage drop. So over here is where my test points are going to be. They're located roughly 1.5 inches apart, or just under 40 millimeters. When the load is connected, I'm going to measure between these 2 points to get a baseline for a wire that's uncut. Over here's the wire nut all ready to go. You can see the conductor was stripped between here and the end where they're twisted together. Now this area is about 20 millimeters or 3/4 of an inch from here in, and the reason for that is because if you look at the wire that is uncut, from the center here, if you cut it to there, would be the distance with the insulation removed from here going in. I'm going to measure the voltage here on the wire, and for this one I'll measure on this side and on the opposite side. And right here's the same thing for the ideal. You can see the insulation is exposed right here, and from this edge of the insulation to the tip where the wire stops on both sides is roughly 3/4 of an inch or 20 millimeters. Now if you take a look at the ideal one, the wires on this are pretty secure. I mean, there's a little bit of movement, but it is pretty secure. Now I want to show you the other ones in comparison. And you can see when the solid copper wire is inserted, I mean the wires, I'm not too thrilled with this. There's a lot of play in that connector. I mean, if I twist it, it's not too bad. Yeah, it moves a little bit, but left and right, not really liking it. And if you're going to make a connection in an electrical box, when you go to shove the wires back in, and you bend the wires, tuck them in, it's going to be moving this all around. So I'm not very happy with that. Let's take a look at the Wago 221. Actually, the worst of all when it comes to movement. I mean, look at this. I mean, there's a lot of play in these things. I don't know if I would trust this inside of an electrical box making just a small contact, because the contact points are very small, and you can see the wire. It goes all the way to the end. Hopefully you can see that. And the levers are locked. Right here you can see how I'm going to be performing the test. The load or loads will be connected at this end. That end over there will be plugged into a dedicated 20 amp branch circuit. Each one of the testing wires will be connected here and there. Okay, everything is now connected up. I need to be very careful. This is hot. Right here is 0.05 millivolts. Measuring right here should say 0.00. So what I'm going to do is deduct 0.05 millivolts from the readings that I get. I have a toaster and hair dryer, and I set the current to 18 amps. So what I'm going to do is turn this on. You'll see the voltage drop, and I'm going to show you the current on a digital clamp meter. Okay, the test is complete. 4.4 millivolts, pretty stable throughout the whole time of 15 minutes. Deduct 0.05, that leaves 4.35. Right here's the temperature of the spot between the probes. You could also see the temperature of the soldered connections stayed as cool as the wire. Okay, let's go on to the next one. Now the wire nut is going to be tested. Just like before, I'm going to deduct 0.05 millivolts. Okay guys, test complete, 15 minutes, just a little bit over 5 millivolts, so slightly higher than the uncut wire. And right here you can see the temperature of the wire nut under load just before the test ended. We're now going to test the ideal connector, same as before, deduct 0.05. The ideal connector was right around 8.2 millivolts, so definitely higher because less surface area of the wire is making contact. Right here you can see the temperature, and it's a little higher than the wire nut. Now this connector right here. And that is it for this connector. 15 minutes is up. We were right around 9.52 millivolts. And right here you can see the temperature of this connection right at the end of the test. The last connector is the one that wiggled the most, the Wago 221. Let's check it out. As you just saw, the Wago 221 had the highest voltage drop out of all of them, and I expected that because the wires wiggled the most within the connector. Right here you can see a temperature reading of this connector at the end of the test. In first place, the lowest level of resistance with the least heating is the wire nut. Not surprising because there's a lot of pressure squeezing the conductors together within this cap. Next is the ideal connector, followed by the lever connector you see here, and last is the Wago 221. As a person that's been working with electrical wiring for at least 33 years, I would suggest if you have a solid copper conductor, 2 to 3 of them, definitely go with the wire nut. The connection is going to be extremely secure, you're going to have a very low voltage drop, and the least amount of heating. If you've ever worked with wire nuts, you're going to know if you try and join 4 or 5 wires together using one of the wire nuts, it could become a little bit of a problem. One of the conductors, as it twists, may push downward, and it may not be a good connection. In that case, and the only case I would suggest, you would use one of these. This one tested better than the Wago. Look for one that has 4 or 5 levers. Slide all your conductors in, lock it down. These are ideal if you're going to be working on your wiring, but if it's new construction, definitely use these. Very few people are going to be modifying the wiring on new construction. And guys, that's it. I hope you found this video helpful. If you did, please share the video. A lot of time goes into making these videos, and they're simply not worth it if not enough people watch the video. So please share. Thanks for watching.